Good day to you all. Today we are taking a topic in mathematics, and that aspect of mathematics is called abstract algebra. Abstract algebra is a kind of a modern algebra. In a layman language, algebra simply means the deployment of letters or symbols and the rules that we follow in manipulating them. Like for instance, everybody know that 5 plus 7 will give us 12. But a kind of mathematics whereby instead of using numbers, you use letter. Like for instance, x plus y is equal to z. In this case now, we are in the realm of algebra because we use letters instead of numbers. When we use number like this, that is called arithmetic. So today there is a particular standard inequality under modern algebra known as abstract algebra, and that is called triangular inequality. It is called triangular inequality. So today's topic, want to prove the triangular inequality under abstract algebra. Now, the inequality that we are about to prove is this: absolute value of a plus b less or equal to absolute value of a plus absolute value of b. A and b, they are elements that belongs to the real number. So now, how do we prove it? We can use algebraic square. We start with a plus b raised to power 2. We know that if we expand this, we are going to have something like a square plus b square plus 2ab. Now, if we deploy absolute symbol, this particular symbol is an absolute symbol. When we talk about absolute value of 5, the answer is plus 5. When we say absolute value of minus 5, the answer is still the same thing as plus 5. So the absolute symbol work is a function on a number. It will transform that number into positive value, whether the number is negative or positive. Now let's use that for this one. Now let's start with absolute value of a plus b, everything raised to power 2. If we expand this, based on this expansion we have here, we are going to have absolute value of a raised to power 2 plus absolute value of b raised to power 2, then plus 2 absolute plus 2a plus 2ab plus 2ab. So now, if you take absolute value of a plus absolute value of b, instead of taking the absolute value of the sum of the two, we take the absolute value of each of them separately. Then if we square it, we are going to have absolute value of a square plus absolute value of b square plus 2 times absolute value of a times absolute value of b. Now, if we compare our results for this first one and this second one, we discover that here the value we have here may be positive or negative, but in this other case, the value we are going to have here will always be positive, which implies that the value we have for here will be less or equal to the value that we are going to have here. So in a nutshell, I will just write this one I will say less or equal to this expression I have here. So what I'm going to write now, like I said, we are going to have something like a square absolute value of a square plus absolute value of b square plus 2ab will be less or equal to absolute value of a square plus absolute value of b square plus 2 times absolute value of a times absolute value of b. Now, since our expression for this one originally was absolute value of the sum of a plus b, then square, we can now say is less or equal to, our original expression for this one was absolute value of a plus absolute value of b, everything raised to power 2. Here we can see that this power will cancel on both sides of the inequality, so we are left with absolute value of the sum of a plus b less or equal to absolute value of a plus absolute value of b. What we have here is an expression known as triangular inequality in abstract algebra. Please do not forget to share, like and comment. Have a nice day. Bye.